So hello guys, welcome back to another video, and in this video we will learn about one of the most important sorting algorithm, which is quick sort. As the name suggests, right? What is its name? Quick, right? So it means it will sort your array, that it will arrange the elements from ascending to descending order or from smallest element to the largest element in very quick fashion. And how does it work, we will understand. What is it, time complexity, we will see everything. But before that, let me just go through my website www.bigdatayatra.com. here you can see our in-depth big data and Apache Spark mastery course. In this we have taught about everything: Spark, Python, DSA, SQL, cloud, project, resume building, LinkedIn optimization, everything. And in this mastery course, Python for data engineers is also included, and there is one separate course which is Python for data engineers. In this you can have just Python and DSA. Okay, so this is it, and let me just go to my OneNote and let's just begin with the quick sort, right? So quick sort, right, it follows divide and conquer approach. Divide and conquer. And now what do we mean by divide and conquer, right? You all must be confused. What is divide and conquer here? Divide and conquer means that if you have array, say suppose if you have this array 1 2 3 4 5 and 6, so suppose you have this array. Now instead of working on this whole array, I will divide this array into two pieces. For example, like this: 1 2 3 here and 4 5 6 here. And now on this first half I will apply my sorting, and on the second half I will apply the sorting, and then I will combine both of it, right? So this is nothing but your divide and conquer. That is, you have divided a big problem into two smaller problem, right? And then this will be further divided into two smaller problem, this will be further divided into two smaller problem, and so on till you solve that problem, right? So this is nothing but your divide and conquer approach. And divide and conquer we have already seen in your binary search, right? If you have not seen my binary search video, I would highly suggest you to watch it. There what we were doing, we were finding the middle element, correct? And as per the middle element and the element we were searching, we were deciding whether to search on the left part of the array or whether to search on the right part of the array by shifting your low and high. So quick sort is also based on divide and conquer approach, where we will divide the array into two halves, right? And then we will apply a recursive solution to achieve my sorted array. Let's see. No more theory, let's just straight jump to the solutioning part. The very first step of my quick sort is to choose one element from unsorted array, which is called as pivot element. The first step is to choose one element from my unsorted array, which will be my pivot element, and this pivot will play a major role in my sorting algorithm. Now, which element to choose as my pivot? This would be your question. Which element to choose as my pivot? Answer is, you can choose any element you can choose as pivot. Any element. It can be your first element, it can be your last element, it can be your median, right? First, it can be your last, it can be your middle element, it can be your largest, smallest, it can be any random element. Any element from my unsorted array, say suppose 8 10 1 6, right? Any element, whether it is 8 10 1 or 6, any element you can choose from unsorted array as the pivot. So this is my very first step of my quick sort. Now once you have chosen the pivot element, once you have decided the pivot element, the next step is to create partitions. This is where we will do the divided. This is where we will do the division of my big unsorted array. So what I will do, create partitions. Create partitions of what? Create partitions of this unsorted array, right? In this step, I will do my divide. I will do my divide. That is, divide one big problem into smaller problems in this step to create partition. And how do we create partition? This we will see. This we will see. Right now, step 3. Once the partitions are created, what we will do? We will do conquer. That is, once I have my smaller sub problems, right? Smaller sub problems, I will work on each smaller subproblem. Which is nothing but your recursion here. And those you don't know what is recursion, please watch my video, full recursion, backtracking, right? Everything is explained in my course. You can check it out. So we will apply recursion at the time of conquer, right? So first step is to choose pivot element, any element. It can be any element from the unsorted array. Then we will create partitions, which is to divide the problem into smaller subhalves, and then finally we will conquer it to apply recursion. And once I have conquered the smaller sub problems, what I will do? I will combine the result. Okay, so this is nothing but your quick sort. Very easy quick sort. Yeah, I know we have just discussed theory. We will see a practical example too. We will see code too. We will see time complexity too. But if you have understood the crux, it will be very easy to understand the workflow of quick sort. So first, to choose the pivot element, right? Then we will divide, that is create partition. Then we will conquer, that is to apply recursion. Then we will combine the results. This is your quick sort. Now let me just take an example and run all the 4 steps, that is choosing pivot, creating partitions, applying recursion, that is conquering, then combining the result. Let me take example of one unsorted array, guys. Right, it will be very clear. Just hold on. Right, so let me just write quick sort example. Let me just take one array. I already have one array with me. It can be, let me just have a look at the array element 6, 3, 11, 12, 7, 4, 1. 6, 3, 11, 12, 7, 4, 1. This is my array, guys. This is my array. 6, 3, 11, 12, 7, 4, 1. And as we know, in Python, the array index starts from 0. So 6 will be 0th index, 3 will be 1, 11 will be second index, 12 will be third index, 7 will be fourth index, 4th will be fifth index, 1 will be at the 6th index. And how many elements I have? Guys? Total elements I have here will be equal to my length of array, and it is nothing but your 7. Correct? Ranging from 0 to 6. Total 7 elements. Now, this is unsorted, right? This is unsorted. Now, we will apply quick sort. That is all the 4 steps: choosing pivot, dividing, conquering, combining. We will choose, right? We will apply. Now, the very first step is to choose pivot. So, we will choose pivot. As I said, pivot can be any element. In this case, from this array, I will choose my first element as pivot. You can choose any random, right? Any random. You can choose this, right? Any. But for now, for explanation purpose, I am choosing my array of 0 as my pivot. Pivot element is my array of 0, which is 6 in my case, right? Now, what was the second step, guys? What was the second step? Second step was to divide. That is, create partitions. Now, tell you one thing, guys. To create partitions, what I will do? I have 6, right? My aim is that my 6 has to be at the correct position, right? Correct position. So the whole idea of creating partition is the 6 should be at the correct position, right? So when will 6 be at the correct position, or when will the pivot element be at the correct position? When all the smaller will be at the left, when elements smaller than 6 will be at the left, and when elements greater than 6 will be at the right. Smaller will be at the left, smaller than 6, smaller than 6, and all the elements which are greater than 6 will be at the right. Then can I say 6 will be at the correct position? You yourself tell. Let's just look at the array 6, 3, 11, 12, 7, 4, 1. Right. So this was my array. 6, 3, 11, 12, 7, 4, 1. Now my pivot is 6, guys. This is my pivot. So to make 6 at the correct position, can I make all the elements which are smaller to 6? That is, let's see. I will start from the first index. 3 is smaller. Yes, 3 is smaller. It will be at the left side. 11 is bigger, 12 is bigger, 7 is bigger, 4 is smaller. Yes, 4 will be at here. 1 will be at here. Right. Now, let's look at the element which are greater than 6. 11, 12, 7. Now, can I say, you yourself look at this array, guys. After dividing. Can I say 6 is at my correct position? Because all the smaller, that is 3, 4, 1, are at the left side of the 6. And all the elements 11, 12 and 7, here it is 7, all the elements which are larger than 6 are at the right side. So, is 6 at the correct position? Absolutely. So my pivot guys, pivot is at correct position. So this is nothing but your step 2, that is divide. And what I have done guys, all the smaller elements to the left side, all the largest element to the right side, and pivot will be at the correct position. Now, have I created the partition? Yes, I have. One partition will be my smaller one, in which I will have 3, 4, 1, 3, 4, 1, and one partition will be my larger, in which I will have 11, 12, 7. I am not bothered about my pivot because pivot is already sorted. Now, step 3, guys. I have written that step 3 is nothing but your conquer. That is to apply recursion. And on which array I will apply recursion? I will apply recursion on these arrays, smaller and larger. So what I can do, I will repeat the same step for my smaller, that is 3, 4, 1, right? First I will apply the same step. Now what is that? Now see, earlier I had this big array, guys, right? You yourself see, earlier I had this big array, correct, of 7 elements. Now how many elements I have? 3. Because I have divided my bigger problem, that is bigger array having 7 elements, to only 3 elements. Now I will again choose pivot. Which will be my 3. So all the elements which are smaller to 3 will be on the left side. So 1 will be at the left. Then I will have 3 because 3 is my pivot. Then I will have 4. Is it sorted now? Yes, it is. Now I will do the same for my larger element. Or larger array, 11, 12, 7. I will choose pivot again as my first element, right? So all the elements which are smaller to 11 will come on the left, that is 7. All the elements which are greater than 11 will come at the right. This is also sorted, yes. So I have conquered it. divided the bigger problem into two sub problems, and then conquered the two sub problems using recursion. And then finally what I will do, guys, I will combine. Step 4 is to combine. And how I will combine this sorted smaller 1 3 4, then I will have my pivot which was 6, then this bigger larger sorted array 7 11 12. Now is this my sorted array 1 3 4 6 7 11 12? Yes it is. Yes it is. So this is nothing but your quick sort. That's it. That's it. What I have done, let me just revise it for you. I have chosen the first element as my pivot. You can choose anyone, right? The idea to choose pivot is to make pivot at the correct position. Now when will be the pivot at correct position? When all the smaller will be at the left side, all the larger element greater than pivot will be at the right side, right? And then finally I have created partitions, that is divided my problem into two sub problems, smaller and larger, and then again applied the same step, that is choosing pivot, making it smaller to the left side, making larger to the right side, right, for the smaller array, right? And then same I did for the larger array, and then at the end in the step 4 I combined it. Okay, and this step I conquer. I will achieve it using recursion, right? Is it clear? Is it clear, guys? If it is clear, now let's just understand the time complexity. Very important interview question. Time complexity. We will see the code also. We will see the code also, but it's important to understand the time complexity. It's important to understand the time complexity, guys. Okay. So in this, I will assume average and best case. First, average and best case. And we will see the worst case as well, because it has two time complexities. Average and best case is different, worst case is different. Let's see. So initially, what was my array? What was my array? 6 3 11 12 7 4 1. 6 3 11 12 7 4 1, right? I chose pivot as 6. I chose pivot as 6. Then what was my smaller array? I divided this into two array, 3 4 1, right? This was my smaller, and then bigger was 11 12 7. So I divided this array element of size n, say suppose, into two halves, that is n by 2 and n by 2. Correct? This is my, and this is my pivot, right? Pivot is my at the correct position. So my array size was n, that is 7 in this case. I divided it in 3 and 3, that is roughly I can say n by 2 and n by 2, right? And then again I will do, I have chosen pivot as 3. Then again I divided the array into two halves. How? 3, and then 1 was here, 4 was here. Again I divided, right? This will again be smaller, this will again be larger. This is my pivot. So there I did n by 4, n by 4, and so on. And till what point I did? Till I have only one element, because one element is already sorted. Okay. So in the best and average case, when the pivot was chosen correctly, right? What do I mean by correctly here? That pivot was dividing the array equally, right? Smaller was also having 3 elements, larger was also having 3 elements. We will see the other side as well. When we will choose incorrect pivot, then only the larger will have all the elements, the smaller will have 0 elements. We will see. That was the worst case. That's the worst case, right? But here, consider pivot was chosen correctly, 6. I have a smaller 3, larger 3. So n by 2 and n by 2. Then again I divided n by 2 array into two halves, n by 4, n by 4, and same, this will be divided with n by 4 and n by 4. And then I will stop, because after this point all the array was having only one element. Here the smaller was 7, then pivot was 11, then larger was 12. So one element, I will stop here. One element, I will stop here. If I would have had more element in the smaller, then I would have done the again same for further, that is n by 8, n by 8, and for this also n by 8, n by 8, For this also n by 8, n by 8, and so on. So how many work I am doing in every step? How many work I am doing in every step, guys? You yourself see. Firstly, n work. Then I had n by 2 plus n by 2. How many work I will have to do? N. Like 2n by 2, it will be n. Then again, n by 4 plus n by 4 plus n by 4 plus n by 4. It is nothing but your n. Right? Then again, n by 8, n by 8 plus n by 8 till 8 times, it will be again n, and so on. So how many work I am doing at each level, guys? N work. And number of levels, right? You yourself see. Initially, I had, say suppose 8 elements, then I divided into 4, then again divided into 2, then again divided into 1. So I will stop here. So how many levels if I have 8 elements? In this case, I had 7, right? 7 elements. So 7, and then I divided into 3, then I divided into 1. So for 7, I did 2 levels. For 8, I did 3 levels. So can I write the number of levels? Number of levels is equal to log 2 of n. That is, for 8, log 2 of 8. For 7, it will be log 2 of 7, and so on. So in general, can I write log n levels? And how many work? Number of work at each level. Number of work at each level. This we already calculated, correct? N. Number of work at each level is n. So total work will be number of levels into number of work at each level, correct? It is very easy to understand that. That's why I am explaining you like this. It is very, very important at each level. So it will be log n into n, because I have log n levels, and number of works I am doing at each level, n. So n log n will be my best and average case time complexity for my quick sort. I hope it is clear. I hope it is not that difficult to understand. If it is that difficult, let me just again iterate. I had array of L size 1, size n, right? What I did, I created 2 more arrays of size n by 2, of size n by 2, smaller and larger, and then I will apply same step on this smaller. I will create n by 4, and then for larger also I will do same step. I will create 2 arrays of size n by 4, etc. So how many work I am doing at each level? N. Then n by 2 and n by 2, it will be n. So at each level I am doing n work, right? And how many levels I have? Say suppose if I have 8 elements, then next smaller and larger array will have 4, then it will have 2, then it will have 1. So how many levels? 1, 2, 3. So it will be log n levels. If 8 elements, so I am doing log 8 work to the base 2, it will be 3. So total work will be n log n. I hope it is clear. So average and best case is n log n for quick sort. Average and best case for quick sort is n log n. Now let me just go to the worst case. Okay, to the worst case. Let's just understand the worst case. What will happen with the worst case? For worst case, say suppose I had this element 6, 7, 11, 12, 7, 4, 1, right? Let's suppose I chose 1 as my pivot, that is the last element as my pivot. Okay, incorrect element. If pivot is chosen as incorrectly, and as I said, we can choose any element as pivot, but let's say we chose 1 as my pivot. Okay, so all the elements which are smaller to 1 will come at the left. Which element is smaller? Is this smaller to 1? No. Is this smaller to 1? No. No elements are smaller to 1. It means all the elements will be at my largest array, that is 6, 7, 11, 12, 7, 4. and smaller will be empty array. It will be empty array, right? So I did n work in this case, right? And how many work I will do in the next step? Smaller is empty, pivot is gone, that is pivot is at my correct index. How many elements are remaining? N minus 1. Now say suppose in my larger array I will again choose pivot as the smaller element, that is 4. Say suppose I again chose pivot as 4, that is again the larger element. Okay, then all the elements which are smaller to 4 will come at left. How many elements are smaller to 4? No one. Then I will have 6, 7, 11, 12, 7. Then how many elements I need to incorporate? 1 is pivot, which is sorted. Okay, 4 was the pivot again. Then I am left with n minus 2. So how many work at each level I am doing if pivot is chosen as the smallest element every time or the largest element every time? It will be n plus n minus 1 plus n minus 2. So n plus 2 plus n minus 3 and so on. This is the amount of work I am doing at each level, which is nothing but your sum of n natural numbers, which is nothing but your n plus 1 by 2, which will be nothing but your n square. So worst case, and what is the worst case? When pivot is always chosen as the smallest or largest element, because one side of your array will be completely empty and only one side will be containing the elements. So when pivot is always the smallest or largest element, it is the worst case for quick sort, and the time complexity will be O(n) square. So worst case time complexity for quick sort is O(n) square, and the best and average case when you chose the pivot element correctly, that is you cannot choose, right? Because you don't know what is the pivot element is correctly, right? So when the pivot element is chosen as such that all the smaller and larger element will always be divided equally, then that is the best and average case. Okay, worst case is when pivot is chosen is always the smallest or largest element, and best and average case is when pivot divides smaller and larger array equally. So that is O(n) log n. Average and best case we have already seen the explanation, and worst case is O(n) square. Okay, if all the things are clear, let me just quickly jump to the PyCharm and let's write code for my quick sort. Okay, this was my array 6, 3, 11, 12, 7, 4, 1. I will create one function quick sort which will take this array. What I will first check, if length of array, this is my initial check, is less than equal to 1, I will just simply return my array. Why? Because if array is empty, this check is checking if array contains only one element, return it. And this will be my base case for recursion. Base case for recursion. If I will not write base case, my recursion will always go on infinite times, and I will have a stack overflow error, right? So it is very important to write base case. And then finally I will create partitions, that is divide. Okay, divide or create partitions. How I will create partitions? I will create partitions for I in array, and I will start iterating from the first element, right? From this 3, 11, 12, 7, 4, 1, because pivot, right? Okay, before that pivot will be my first element. Let's say pivot will be my first element. Okay, so what I will do, for I in range 1, if I is smaller than pivot, guys, what I will do, I will create two array, is smaller, empty, and larger is empty. This is clear, right? I am first step is to choose pivot. Step 2 is this, to create partitions, and this we have already seen. Okay, so shouldn't be a problem for you. Step 2 is divide, create partitions. To create partitions, I have created two empty arrays, smaller and larger, and I am iterating from the first element of the array 3, 11, 12, 7, 4, 1. If any element is smaller than this, I will do append in smaller array the element, right? Else I will do append in larger array. Simple. Any confusion, guys? And I have to apply for I in range this, if yes, one array, that is correct. Now I will conquer. I will conquer. How I will do conquer? I will just simply return. I will again call this a quick sort for my smaller, and then I combine also with pivot. Then I will call again quick sort. Let me just decrease the font. Again will call quick sort for my larger. Is it clear? This is my quick sort. Is it clear, guys? Is it clear? What I have done, this is the base case for recursion. If length of array is less than equal to 1, this is we were doing, right? We were stopping. When we were hitting the array of size 1, we were stopping, correct? So that is the base case for recursion. I am just writing if array length of array is less than equal to 1, return it. Step 1 is to choose pivot. I have chosen first element. You can choose any. You can choose any. Then step 2 is to divide. I have created two partitions, smaller and larger. If element is smaller than pivot, add to smaller, else add to larger, and then conquer it by applying recursion and combine at every step. Okay, and now before this I will just print my smaller, pivot and larger, so that you will be able to differentiate, okay, at every step. Now let me just call the quick sort array and print the final result. Let me just run it, guys. You will yourself see. Yes, is it running? I had this array, guys, 6, 3, 11, 12, 7, 4, 1, right? Initially what I did, 3, 4, 1 created the smaller array, 6 is my pivot, then 11, 12, 7 got created as my larger array. This you can see output at every step. After this, it worked on smaller array 3, 4, 1, then all the elements having 1, it got returned because this is my base case, then it conquered for right array, then it combined 1, 3, 4, 6, 7, 11, 12, right? And this is nothing but my quick sort, guys. So I hope it is clear. This is nothing but my quick sort. And yes, so best and average case time complexity is n log n, worst case is O(n) square. I can further improve this. Step by list comprehension. How I can do? I can just simply write for I in array 1 से लेके last तक, if I is smaller than pivot, right? That's it, one liner list comprehension. Larger will be I for I in array 1 से लेके last तक, if I is greater than pivot. That's it. If I run this, I will again get the same result and my array is sorted. So I hope this is clear. We have seen how to create partitions using loop and list comprehension both, and then conquering it, applying the same step again and again. And this is my base case for recursion. In this I have chosen the first element as array. You can choose any, and in that your time complexity will be O(n) square if a pivot is always chosen the smaller or large. Give it a shot. It is very easy. I hope I am able to make you explain quick sort. We will meet in next program. See you all. Jai Hind.